Now, good morning, my dear children. Today we are going to discuss the KEAM questions of last year, Unit 8. ഇന്ന് നമ്മുടെ ടാർഗറ്റ് കഴിഞ്ഞ കൊല്ലത്തെ KEAM examination questions ആണ് Unit 8. Unit 8 includes atoms, nucleus and semiconductors. അത് ഇത്രയും atoms എന്ന് പറഞ്ഞ ചാപ്റ്റർ ഉണ്ട്. ന്യൂക്ലിയസ് ന്യൂക്ലിയർ ഫിസിക്സ് അതിൻ്റെ ചാപ്റ്റർ ഉണ്ട്, സെമി കണ്ടക്ടർ ചാപ്റ്റർ ഉണ്ട്. അതിൽ നിന്നുള്ള ചോദ്യങ്ങളാണ് നമ്മൾ യൂണിറ്റ് 8 ഉൾപ്പെടുത്തിയിട്ടുള്ളത്. ദിസ് ലാസ്റ്റ് യൂണിറ്റ്. വി ക്യാൻ സ്ട്രേറ്റ് അവേ എൻ്റർ ഇൻ ടു അവർ ക്വസ്റ്റ്യൻസ്. നമുക്ക് നമ്മുടെ ക്വസ്റ്റ്യൻസ് കിടക്കാം. ആദ്യത്തെ ക്വസ്റ്റ്യൻ ദർ ഓൺ ദി ബോർഡ്. The ratio of the velocity of the electron in second, third and fourth Bohr orbit of hydrogen atom. You know the property of electron in an orbit. Physical property of electron in an orbit depend on the quantum number n, in which angular momentum proportional to n, velocity proportional to 1 by n, radius proportional to n square, energy proportional to kinetic potential or total proportional to 1 by n square. Then time period proportional to time period of revolution proportional to n cube. T proportional to t square proportional to cube. R proportional to n square. Therefore, it is better here. It is better here, right? Proportional to n cube. Then linear or angular frequency proportional to 1 by n cube. These are the dependents. Some of the dependents of the physical property of electron in an orbit in Bohr atom. A principal quantum number ഏതെങ്കിലും ഒരു നമ്പറിൽ ഓർബിറ്റലിലെ ഏതെങ്കിലും പ്രോപ്പർട്ടി തരികയാണെങ്കിൽ അതേ പ്രോപ്പർട്ടി വേറെ ഏതെങ്കിലും ഓർബിറ്റിൽ നമുക്ക് കണ്ടുപിടിക്കാൻ ഈ ഫോർമുലകളൊക്കെ നമുക്ക് അല്ലെങ്കിൽ ഈ ഡാറ്റകൾ നമുക്ക് ഒരുപാട് ഉപയോഗമുണ്ട്. കുറച്ചെണ്ണം എഴുതിയത് മാത്രമേ ഉള്ളൂ. ഞാൻ എഴുതിയാൽ ലൈക്കിനും നിങ്ങൾക്കറിയാം കറസ്പോണ്ടിങ് ഇക്വേഷൻ എന്താണെന്നുള്ളത്. ആർ പ്രൊപ്പോർഷണൽ ടു എൻ സ്ക്വയർ ബൈ സെഡ്, പി പ്രൊപ്പോർഷണൽ ടു സെഡ് ബൈ എൻ, എനർജി പ്രൊപ്പോർഷണൽ ടു സെഡ് സ്ക്വയർ ബൈ എൻ സ്ക്വയർ. ഇതെല്ലാം ഹൈഡ്രജൻ ലൈക്ക്, അതും നമുക്ക് അറിഞ്ഞിരിക്കേണ്ടതാണ്. നമുക്ക് നമ്മുടെ പ്രോബ്ലത്തിൽ പോവാം. ഹിയർ that what are the velocity ratio in second, third and fourth. Velocity depend on the wind. Therefore, V2 is to V3 is to V4, 1 by 2, 1 by 3, 1 by 4. 12 നിങ്ങൾ എൽ സി എടുക്കുകയാണെങ്കിൽ 6, 4, so 6 is to 4 is to 3. That is the ratio 6 is to 4 is to 3. So option is 2. ഈ റിലേഷൻ നമുക്ക് ഒരുപാട് ആവശ്യമുണ്ട് എന്ന് ഓർക്കുക. അതെല്ലാം നമ്മുടെ മനസ്സിൽ ഉണ്ടാവും വേണം. We can go to our next question. Plutonium. Plutonium nucleus undergoes fission with. Plutonium is a man-made fuel derived from the fertile material uranium-238. uranium-238 ഒരു ന്യൂട്രോൺ ക്യാപ്ചർ നടത്തി 2 ബീറ്റാ ഡിക്ക് നടന്നു കഴിഞ്ഞാൽ നമുക്ക് പ്ലൂട്ടോണിയം, നെപ്റ്റ്യൂണിയം, ദെൻ പ്ലൂട്ടോണിയം. പ്ലൂട്ടോണിയം ഇസ് എ മാൻ മെയ്ഡ് ഫ്യൂവൽ. ആ മാൻ മെയ്ഡ് ഫ്യൂവലിൽ ആരാണ് ഫിസൈൽ പാർട്ടിക്കിൾ എന്നാണ് ചോദ്യം. സ്ലോ ന്യൂട്രോൺ. അതിന് വേറെ ഉത്തരം വേണ്ട. യു ക്യാൻ യൂസ് uranium-235 or this plutonium, and fissile particle is slow neutron. So slow neutron. Remember, plutonium is a man-made fuel. Go to our next question. Out of the following, where the element identify isotones. Isotone means exoneutrons. Exoneutron number same hour. Exoneutron number same hour. A minus Z value same hour. A minus Z value. If same, they are called isotones. A minus Z value. So now we are given when A minus Z value you calculate and see which one satisfy, which will give you the same value out of the elements given there. And if you go to our box, the difference is 197 minus 79 will do 8, 1, 1. Here 198 minus 80, 8, 1, 1. Therefore, the extra neutron number is the same. Therefore, these are isotopes. നമുക്ക് അടുത്ത ചോദ്യത്തിലേക്ക് പോവാം. If EC and EV represent the energy of conduction band and valence band, and ED and EG represent the donor energy level and band gap in n-type semiconductor, then the two relationship. If you draw this is the, suppose this is the valence band and this is the conduction band. The valence band, this is conduction band. Energy in these two are given to you. Conduction band EC and valence band EV. So here the energy is equal to EV and here it is equal to EC. In the next data that is given there. ED and EG represent the donor level of n-type. Donor level of n-type. Donor level of n-type is very close to the conduction band because electron donated from that nearby energy state, which is called the donor level. This is the donor level. Energy there is equal to ED. In energy band is the EC minus EG. This is EG. ഇനി ആരെ വലുത് ആരെ ചെറുതെന്ന് ഇവിടെ നോക്കിയാൽ നമുക്കറിയാം. ഇനി ഇതിൽ ഈ റിലേഷനിൽ നിന്ന് നിങ്ങൾക്ക് അവർ ഓപ്ഷനിൽ എന്താ ചോദിച്ചിട്ടുള്ളത് അതും കൂടി നമുക്ക് ഉത്തരം പറയാം. ഒന്നും എന്താ പറയാം, എന്താണ് EC minus EV is equal to EG. ഇനി EC this plus this is equal to EG. എങ്ങനെ എത്ര വേണേലും പറയാം. അതിൽ ഏതാ കറക്റ്റ് ഓപ്ഷൻ? You go and see. There you can see that there are options. This level ED is less than EC. It is very nearer to conduction band and is much away from valence band. അത് വെച്ച് നിങ്ങൾക്ക് അതിനകത്ത് ഇത് ED greater than പറയുകയാണെങ്കിൽ ഉടനടി പറയാം greater than EV. So ED greater than EV or ED less than EC. That is also correct. But here the correct answer is ED greater than EV. ED greater than EV. Next. During the formation of PN junction, when you fabricate a PN junction, some question asked, while we fabricate a PN junction diode, the majority hole diffuse from n-type p side. You know, majority carrier diffuse from their majority region. Holes are majority there in P. So, 4 holes diffuse from higher concentration region, that is the P region, PN region. And that is what is called a minority injection, because they are minority on reaching N region. And there was diffusion take place from P to N holes, where electron diffusion take place from N to P, constitute current, diffusion current from P to N. Hole diffuse, electron diffuse, both constitute current in the same sense or same direction. That is from P to N, that is the diffusion current. ഇവിടെ ചോദിച്ചതിന് ഉത്തരം. During PN junction, majority holes diffuse from N to theta, majority electron diffuse from P to theta. Ionized donors, no. Ionized acceptors are there on N side, there is donor. 11th option. The space or the region on either side of junction is called depletion region. There you know, because of the diffusion from P to N, when hole diffused in, they are neutralized by the electron here. Similarly, electron diffused here, neutralized by holes here. This region become depletion layer region. So there is a depletion layer region with a barrier potential across that which is called potential barrier. That is the theory we studied. ഇവിടെ എന്താണ് അവിടെ ഉണ്ടാവാൻ പോകുന്നത് junction? There is the depletion region is there. The space charge region on either side of the junction is called depletion, which is depleted of carriers. That is why it is called depletion layer region. Next question. Question is the energy required. The energy required to excite a hydrogen atom from its first excited state to a second excited state. Now, in hydrogen atom, ground level n is equal to 1. Energy is minus 13.6 by n square. 1. N is equal to 2. Minus 13.6 by n square, 2 square. That's 3.4. N is equal to 3. Again, minus 1.51 electron volt. This is our energy. And this is the ground state. First excited, second excited. And what is asked there? Energy required to excite a hydrogen atom from first excited to second excited. From here to here. Difference. Magnitude of 3.4 minus 1.51. That one calculation is equal to 1.89. So this difference is 1.89 electron volt. So that is our answer box. Then energy relation, you know, hydrogen minus 13.6 by n square. Next question. The maximum number of neighbors of a nucleon within the range of nuclear force is P, and K is a constant of proportionality. Then the binding energy per nucleon is approximately. You know, in a nucleus, the nuclear binding force is not among all the nucleon within the nucleus. One member of this nucleus should not have nuclear force of attraction between all nucleons inside that nucleus. But it gives nuclear binding force between the neighbors with the radius equal to nuclear range, which is very, very small fraction of or the order of Fermi. So the nucleons inside this nucleus, in this area, the nucleons inside this volume keep nuclear force with this one. Not all the nucleons inside the nucleus. Now come to our question. Now how many number of nucleons are there? If P is the number of, if range of nuclear force is P, and if the maximum number of nucleon neighbors of a nucleus within the range of nucleus is P, so number of nucleons inside is P, and K is a constant. Then the nuclear force proportional to P or equal to Kp, where K is a constant. Therefore, E is equal to Kp. Question framed then, a nucleon within the nucleus should not have nuclear force with all other members of that nucleus. It extends the force between the neighbors, close vicinity neighbors, whose range is the nuclear range. Yes, next question. Gamma emission, the nucleus emit. In gamma is the electromagnetic radiation. In a nucleus, from a nucleus during gamma emission, you get electromagnetic radiation, gamma rays, whose wavelength is much less than 0.01 angstrom. Very high energy nuclear radiation, gamma radiation. And emitted one is the photon. A gamma photon has got the maximum energy. Now, next question. The initial time rate of radioactive sample. Initial decay rate of radioactive sample is R0, then the decay rate after a half-life time T half. Now, nuclear activity, radioactivity, that is not strictly as per the present syllabus, but they ask the question, therefore we are discussing this question. Now, Rutherford decay law says that rate of decay, number of nucleus decay per second, dN by dt, rate of decay, proportional to number of undecayed nuclei present in the sample. അത് ഏകദേശം നമ്മൾ കൂടുതൽ കാശിന് കൂടുതൽ പൈസ സ്പെൻഡ് ചെയ്യും. മൈ സ്പെൻഡിങ് എക്സ്പെൻഡിച്ചർ അല്ലെങ്കിൽ മൈ എക്സ്പെൻഡിച്ചർ റേറ്റ് ഡിപ്പെൻഡ് ഓൺ മണി ഇൻ മൈ പോക്കറ്റ് എന്ന് പറഞ്ഞ പോലെ ഇത് കൂടുതൽ നമ്പർ ന്യൂക്ലിയോൺസിനെ കൂടുതൽ പേര് ഓരോ സെക്കൻഡിലും ഡിസെൻറ്റിഗ്രേറ്റ് ചെയ്യും. ഇതാണ് റുദർഫോർഡ് സോഡി ലോ, dN by dt proportional to KEAM. In our problem, initial decay rate R0 proportional to KEAM, where n is the number of nuclei. Now, then decay rate after half-life. After one half-life, what will happen? Then number of nuclei, coupled disintegration, reduced to half the earlier number. The earlier number is n. So after half-life, after one half-life, the number n become, then again by Rutherford-Soddy law, what is the decay rate now? The decay rate R dash proportional to number of nuclei n by 2. The case number 1, the case number 2. Now R2 is 2 by 1. Give you R dash by R. N by 2 by n. Or R dash is equal to R by 2. R dash is equal to R by 2. So option is equal to 11. And external. An external voltage V is applied to a semiconductor diode having built-in potential V0. Built-in potential means the potential barrier potential is V0. The effective barrier height under the forward biasing. Under forward biasing, suppose this is a diode. P. Here there is depletion and potential barrier voltage is like this. This is the built-in voltage. The built-in voltage is given to you as V0. V0. Now when you apply V, forward bias, when you apply V, forward bias is plus is minus, when you apply, that reduces the effective barrier potential. Suppose the applied potential is equal to V, the effective barrier potential become V0 minus V. And therefore the answer, what will be the effective barrier height? Barrier height means barrier potential reduces because you applied a voltage, forward bias voltage. Therefore, whereas you apply reverse bias voltage, what happens? Barrier potential again increases. Above the V0 plus V. The V0 minus V. Therefore, the answer. V0, that is the answer. Answer is not there. Either V0 equal to now. അവിടെ എന്താണ് എഴുതിയുള്ളത്? V0 equal to എന്നാണ് എഴുതിയത്, അതല്ല. ഇപ്പോൾ V0 minus V. V0 minus V. If that is not there, then there is no answer. That's okay. Next. The conductivity. The conductivity of a material lies in the range 10 raised to 2 to 10 raised to 8. Conductivity is very large. Conductivity since very large, definitely is a good conductor. It's a good conductor. That is the option. Metal. It's a good conductor or it's a metal. because conductivity is very large. Therefore, it's a good conductor. When you scan the option, good conductor is there is a metal. That's okay. The thickness of depletion layer on either side of a p-n junction is the order of. When you fabricate a diode, depletion layer formed at the junction, and the thickness of the depletion layer definitely depend on doping. Generally, that is measured of the order of micrometers. So, it's of the order of micrometer. It's not a fixed one, that depend on doping concentration. But generally, that is the order of micrometer. That's it. Shall go to our next question. Particle which is expected to emitted along with the Y in the following nuclear reaction. Here, you know mass number and atomic number must be conserved during nuclear reaction. Mass number conservation we apply, it is 107, it is equal to 137. No. Question is, the particle which is expected to be emitted along with the Y in the following reaction. Question is wrong. Wrongly came in. Following nuclear reaction is, but this reaction is not that. It is wrong. It is not going to be a particle because you can see that here is 107, this is 137. Never happens. Here the mass number is 107, here mass number is 137. Mass number increases by 30 times. So such a reaction is not possible. So this reaction is wrong. Now note down the reaction, actual reaction. It is not that, but it is X 198 80 give you Y 197 79 plus a particle. Now you can balance mass number conservation and atomic number conservation. Here 98, here 97 plus 1, here is 1. Our particle should have mass number 1. What about atomic number? 80, 79, atomic number missing is 1, 1. Therefore, is equal to H1, 1, proton. Therefore, the emitted particle is a proton. This is not the reaction, this is the reaction. I will correct the question and get you. Shall we go to our next question? In nuclear fusion, in a nuclear fusion process, the fusing nucleus Ma and Nb, the two particles are Ma and Nb, nucleus Ma and Nb. Then mass of the product nucleus Mc. Definitely, Mc is the product. And the total mass of the reactants, Ma plus Mb. When they fuse to form this one, definitely some mass will be converted into energy. Therefore, we can say Mc is less than Ma plus Mb. Mc less than Ma plus Mb. So the difference in mass is released out as energy. Next question. 15. The electron concentration Ne and the whole concentration NH in a semiconductor related to number of intrinsic charge concentration Ni. Our question Ne and H in a semiconductor means strictly is an extrinsic semiconductor. So in an intrinsic semiconductor, Ne is equal to NH is called Ni. They are same. But here Ne and NH are different, therefore, definitely that is extensive semiconductor. Now, what is the relation? You know, Ne into NH is equal to Ni square, valid for all semiconductors, whether it is intrinsic or extrinsic. If it is intrinsic, very clear, Ni is equal to Ni square. Extrinsic semiconductor. Ne, if N time electron concentration is more, Ne greater, then energy decreases. So that the product always a constant Ni square. So that is the relation. Ne into NH is equal to Ni square. Next question. The half-life period of a radioactive element is 2 days. If 1 by 32 part of the initial amount remain undecayed after a time t, then what is t in days? Now, we know 2 is the half-life. Therefore, initially if it is 1, in one half-life, you go 1 by 2. One more half-life, half of it, 1 by 4, 1 by 8, 1 by 16. How many half-lives are required? 1, 2, 3, 4, 5. 5 half-lives are required. So that this becomes 1 by 38 or 1 by 32. Question is 1 by 32 part of the initial amount remain. Then how much half-life required? 5 half-life. What is the span of 1 half-life? 2 days. 5 into 2. 10 days. So option is equal to box. Or we can write one more. N by N0, 1 by 2 raised to n. Where n is the number of half-life in given time. Here n by N0, another method. N by N0 is equal to 1 by 2 raised to n. N by N0 is equal to 1 by 32. It's equal to 1 by 2 raised to n. 32. 1 by 2 raised to 5. It's equal to 1 by 2 raised to 5. Equal to 1 by 2 raised to n. 1 by 2 raised to 5 means 1 by 32. Therefore, n is equal to 5. Number of days, n into 2, that is equal to 10. Therefore, the option. Better follow this method. It's okay. When diode is reverse bias, when reverse bias, definitely you can see that barrier width, depletion layer width increases, resistance increases, then potential barrier voltage, that barrier width increases mean barrier potential increases. Now, what is here? Diode reverse bias, applied voltage PN junction is, N side is positive. Applied voltage in P side is positive, wrong. Depletion layer width decreases, wrong. Applied voltage in the opposite direction of barrier potential, wrong, reverse bias. Minority carriers are not allowed to cross the barrier, wrong. Minority current is there. Barrier height increases because the applied voltage added with the potential barrier. Therefore, we get it added. The forward bias decreases or reverse bias it increases. Therefore, the option is E. Next question. Bohr atom model is invalid for, not valid but invalid. Bohr atom model is valid only for hydrogen or hydrogen like. Hydrogen like means singly ionized helium, doubly ionized lithium. That here invalid. Hydrogen atom, it is valid. doubly ionized helium atom wrong. Singly ionized helium atom is correct. Doubly ionized helium atom Bohr atom model is not valid, invalid. Doubly ionized helium atom, it is invalid. Energy equivalent of 1 gram mc square. This one calculation is equal to 9 into 10 raised to 13. And that is the energy in joule. Next. Mass number of two nuclei are in the ratio 2:3. The ratio of the nuclear density would be. Nuclear density is independent of mass number. All the nuclei of all elements, nuclear energy density is the same. It's equal to 2.7 into 10 raised to 17 kilogram per meter cube. And is a constant for all elements. Nuclear density, not nuclear, not atomic. Nuclear density is the same, therefore it's 1:1. Nuclear density is independent of mass number. Therefore it's equal to 1:1. For hydrogen atom combined to form helium atom with the release of 26.7 MeV of energy. What is this called? This is lighter thing combined to form heavier one. There is a fusion reaction or thermonuclear reaction or fusion reaction. So fusion reaction. See, almost all questions are directly theory based. Required of 1 or 5 seconds to give the answer, provided you have got the proper knowledge. In a circuit given below the current. Now see, look into the circuit, see the status of the diode, whether it is forward bias or reverse bias. With respect to N, if this is the higher potential, forward bias. With respect to N region, lower potential, reverse bias. Here you can say this here is -2 and here is -5, lower. With respect to N side, this is a lower potential, therefore it is the reverse bias, won't conduct. Therefore current becomes 0. It is a reverse bias. And therefore it won't conduct. How you assess whether it's forward bias or reverse bias? With respect to N side, if P side voltage is more, forward bias. If it is less, reverse bias. Electric conduction in a semiconductor is due to. In a semiconductor, when it conducts, there are two charge carriers, both holes and electrons, and they are responsible for current in a semiconductor, both the electrons and holes. In a semiconductor, there are two types of charge carriers, holes and electrons. For a given radioactive metal, mean life and half-life. Mean life 2 and half-life T half, how they are related. You know, T half is equal to log 2 by lambda. T mean or T average is given by 1 by lambda. Substitute here, T half is equal to log 2 into T mean. ആ റിലേഷൻ വരാവുന്നതിൽ ഏതാന്ന് നോക്കാം. or T half. T half is equal to log 2 T mean. T mean is equal to 2. So T half is equal to T log 2. So option is equal to box. Next question. the constancy of the binding energy per nucleon in medium size nucleus is used. Why it is a constant? For nuclei with the mass number from 30 to 170. Binding energy per nucleon found to be a constant, or its nucleus become more stable. Reason: short range nature of nuclear force. The nuclear force, earlier we discussed in a question, the nuclear force is not between one nucleon and all other nucleons inside the nucleus, but among the neighbors. That is why the short range of the nature of the nuclear force is the cause of it. Therefore, the option is C. Otherwise, when the size mass number increases, the binding energy per nucleon must go on increase. It is not so, because nuclear force is a short range force. In a radioactive decay, fraction of number of atoms left undecayed after a time t equal to, n is equal to the exponential decay law, and 0 e raised to minus lambda. What is the fraction? So n by n 0. So e raised to minus lambda. So e raised to minus lambda t. E raised to minus lambda t. Equal to e raised to lambda t. So option is not there. Correct option is equal to e raised to minus lambda t. That is the correct answer. Next. In electron emission process. In an electron emission process, you are given a reaction. Then the particle Q emitted along with the electron. Here, I cannot read. Here there is electron. And the question is, what is this particle? Now, here the equation is not balanced. The reaction is wrongly represented there. Reaction has to be rewritten like this. Something wrong with this one. The reaction I am going to write X ZA give you Y Z plus 1 A. This is the beta decay reaction, strictly speaking. Negative beta decay plus. And what is that particle? That is what is asked. And definitely this is the negative beta decay. That is neutron converted into proton. Therefore, the atomic number remains the same, mass number increases by 1. The electron produced come out along with the particle anti-neutron. To balance this, to explain what is called the energy spectrum of beta ray emitted, evidently there is not only one particle is followed, there are two particles. Then only energy of the beta ray spectrum can be continuous spectrum of beta can be explained only if one more particle is emitted along with the electron in negative beta decay, and that particle is anti-neutron. So you are asked to find out that reaction. Next. The current flowing from P to N side in a PN junction, irrespective of biasing, is termed Now, when a diode is fabricated, there is no biasing. Still there can be a current. From P to N, from P, majority carrier holes diffuse into the N region. At the same time, majority carrier from N side diffuse into the P region. And that flow constitutes a current. And that current is due to diffusion process, and it is called diffusion current. A majority carriers causes diffusion current. Therefore, the name diffusion current. Whereas drift current is due to minority carriers. Whereas diffusion current due to majority carriers. Here it is the diffusion current, because majority carrier holds from P region, because of their concentration gradient is more, diffuse into N region, constitute a current from P to N. Similarly, electron diffuse from N to P constitute a current from P to N, and that is diffusion current. Next, energy required by electron to cross forbidden band of germanium. Germanium, energy required for germanium forbidden energy. What is the forbidden energy gap? Band gap energy of germanium? 0.7 volt, 0.72 volt. And here the energy is 0.72 electron volt. Knowledge question. Next, when hydrogen atom is excited from ground state, from N is equal to 1 to go to higher energy levels, N is equal to 1, 2, 3, etc. Definitely the potential energy increases, kinetic energy decreases. The speed of the orbiting electron decreases as we go to higher orbit. Therefore, kinetic energy decreases, whereas the potential energy increases. So, potential energy increases, kinetic energy decreases. Next, in nuclear decay, after emission of one alpha particle and one beta particle, question is, atomic number remain unchanged. So, what happened to the atomic number and mass number, etc.? Suppose that undergo alpha decay, on alpha decay, this become A minus 4 and Z minus 2. In beta decay, if it follow beta decay, mass number remain the same, beta decay. And therefore, what you can write? After one alpha and beta decay, one alpha and beta decay, now next one beta, you get Z minus 4. Mass number will be the same. But now number increases by 1. So minus 2 plus 1 minus 1. And here you can see that this undergoing alpha as well as beta, what happened? Mass number decreases by 4, whereas, atomic mass number decreases by 4, whereas atomic number decreases by 1. Now options. Or mass number. So atomic number remain unchanged, wrong. Mass number reduces by 4, that is correct. In atomic number decreases by 1, that is also correct, but that option is not there. It's okay. So option is equal to box. The nucleus of tellurium 12552 is 6 Fermi. The nucleus radius of aluminum 27. You know, radius R is equal to R0 raised to 1 by 3. Nuclear radius, empirical relation, connected with the mass number is R is equal to R0 raised to 1 by 3. Now, in first case, we are given that tellurium 125, 6 Fermi. So 6 proportional to R0 is a constant. Is equal to mass number is 125. 125 all raised to 1 by 3. That is proportional to 5. Second, I don't know. Therefore, X proportional to aluminum. Radius, I don't know. But mass number 27. 27 raised to 1 by 3. Question number 1. 2 by 1 gives X by 6 is equal to 3 by 5. Therefore, X is equal to 3 into 6 by 5. 3.6. So option is equal to A. Next. Half-life of radon is 3.5 days. Above the amount of radon left out of 12 milligram and decayed after 35 days. 35 days, you know, n by n0, 1 by 2 raised to n, where n is number of half-lives in given time, T by T half, n is equal to. T is given you the time after which the question is 35 days. Half-life of radon is given to 3.5 days. Therefore, n by n0 is 1 by 2 raised to 10. N by n0 is equal to 1 by 2 raised to 10. Therefore, n is equal to n0 by 2 raised to n. And corresponding mass. So, m is equal to m0 by 2 raised to 10. M0, what is the initial mass? 12 by 2 raised to 10. 12 by 2 raised to 10. 2 raised to 5 means 32. Of 32 into 32. This is on calculation. 4. 3 by 8 into 32. Roughly I am going to say. This is 1 by 10. Approximately is 1 by 80. 10 times 80. 1 by 80 means 0.012. 1 by 80 means 0.012 milligram. That is the amount remaining. Therefore, the option is equal to box. Next question. In PN junction diode, reverse biasing. നേരത്തെ ചോദ്യം ചോദിച്ചാണ്. Potential barrier increases. Reverse biasing increases the potential barrier. Repetition. Which one of the following is not a semiconductor? അതിൽ നിങ്ങൾക്ക് നോക്കിയാലും അറിയാത്ത ഏതാണ്? So options equal box. Now that finishes our questions that belong to question number, chapter number, unit number 8. We finish that. Then one good question, copy down, and we can do that question. Now I cannot get the question here. Now copy down a question. It's over. Now, a mass 60 kilogram and 60 kilogram attached the balloon. Accelerating up with an acceleration with the 4 meters per second square. A mass 60 kilogram attached with a balloon, accelerating up with the 4 meters per second square. Question: how much mass to be added so that the balloon accelerates down with the acceleration 4 meters per second square. How much mass? Now, earlier, suppose the balloon whose volume remains the same and the mass is attached to 60 kilogram, accelerating up. Why it is accelerating up? Net force is upward, which then force due to buoyancy more than this. The net force when accelerate up is equal to force due to buoyancy up minus 60 kilogram. This is the net upward force called mass into acceleration. The FB is equal to 60 into 40. Take into the question number 1. Note it. Equation number 1. FB is equal to 60. Net force is equal to mass into acceleration. Now from this FB, the force due to buoyancy generated by this balloon, now you got is equal to 60 into 10 plus 4, 40. Now the other part, now we are adding some mass, capital M. In that case, we can draw the figure like this. Here is 60 plus M. And here is FB itself. And is accelerating down with the 4 meters per second square. Now net force downward is more. How much? In second case, net force I am again writing. That's equal to net force downward is more. 60 plus M into G minus upward force remains FB equal to net force mass accelerating down 60 plus M. That's the total mass accelerating down into acceleration per unit. Now substitute FB here. 60 plus M into 10 minus 60 into 14. Instead of this one, FB. Substituting for FB here equal to 60 plus M now here only one unknown is the M. M can be calculated. What is that M? M is the mark that you have to add further, so that this has to go down with an acceleration. Solving this, get the value. Okay. Now it is time. See you next class. Next class, നന്നായി പരീക്ഷ എഴുതാനായിട്ട് നോക്കുക. നമുക്കറിയാം വളരെ സിമ്പിളാണ് ഇപ്പോൾ ക്വസ്റ്റ്യൻസ് ഒക്കെ. ഒരുപാട് തലപൊഞ്ഞ് ആലോചിച്ച് ചെയ്യേണ്ട പ്രോബ്ലങ്ങളൊന്നും അതിനകത്ത് നിങ്ങൾ കണ്ടിട്ടേ ഇല്ല. ബേസിക് തിയറി ഫോർമുല, അതിൻ്റെ ഡിറക്റ്റ് ആപ്ലിക്കേഷൻ. ഒരു 97% ക്വസ്റ്റ്യൻ അങ്ങനെ എഴുതും. അപ്പോൾ ആ തിയറി ക്വസ്റ്റ്യൻസ്, തിയറി കൺസെപ്റ്റ്, ഫോർമുലകളൊക്കെ നമ്മുടേതാക്കി മാറ്റാനായിട്ട് ശ്രമിക്കാം. ആൻഡ് അറ്റംപ്റ്റ് much number of possible question. എവിടെ നിന്നൊക്കെ ക്വസ്റ്റ്യൻ കാണാൻ പറ്റണോ ഈ റേഞ്ചിലുള്ള, അല്ലാണ്ട് വലിയ ആനക്കാലം ക്വസ്റ്റ്യൻസ് അല്ല പറയുന്നത്. എത്രയും കാണണോ അത്രയും കാണുക, അത്രയും ചെയ്യുക, ആൻഡ് എക്യുപ്പ് യുവർസെൽഫ്. സോ താങ്ക് യു. സീ യു നെക്സ്റ്റ് ടൈം. ഗോഡ് ബ്ലെസ്.